Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can help me promote my channel to keep me going, inspired, and refreshed. I find my videos interesting to your studies. Also, please don't forget to subscribe. Analyze the rigid frame shown by moment distribution method by determining the moments at all joints. EI is constant. So here is the given frame. So remember that we have this sideway displacement for AB, BC, CD, and DE. So the technique here is we first imagine that DE is fixed, held to be vertically straight, and we apply the sideway delta 1 at B and express BC and CD, the sideway of BC and CD in terms of the sideway displacement at B. In the second part, we hold AB to be vertically straight, no sideway, and due to sideway at D, which is denoted delta 4, then we can express the sideway displacement of CD and BC in terms of delta 4. In general, this will be the deflected shape of the frame. So that's delta 1, this is delta 4. The reason why delta 4 has lesser sideway displacement compared to the sideway displacement at B because the load is closer or acting at B. And for C, to locate C, we draw lines parallel to BC as well as parallel to CD. So we call this C1. CC1 is also delta 1 as shown. Then we have C sub 2 here. CC2 is delta 4. So this is the final position of point C due to the displacement, sideway displacement delta 1. So call this theta 2, theta 3. Theta 2 is arctan of 3 over 4, so 36.87, while theta 3 is arctan of 3 over 7.2, so 22.62 degrees. So this is delta 1. Then from the end of BC, the line parallel to BC, we draw line perpendicular to BC to locate the final position of C, and we call that CF. Then from the end of C2, we draw line perpendicular to CD or C2D1 to locate the final position of C. So due to delta 1, moment distribution due to sideway delta 1 at B. So DE will have 0 sideway, and we call the moments due to sideway as R1. So this is delta 1. So that's the end of BC, and this is the triangle for relating the displacement of CD in terms of delta 1 as well as for BC in terms of delta 1. So perpendicular, then perpendicular. Then the line through CF1 perpendicular to CC1 will have an angle, namely, so angle between the vertical and this one, this is denoted delta BC1, is equal to theta 2, and the angle between the vertical and this side of the triangle, which is perpendicular to CD, is theta 2. So we draw a vertical line. So this is theta 2. This is delta BC1. And this is theta 3. This side is delta CD1. So delta BC1, delta CD1. So this angle is 90 minus theta 3, 90 minus 22.62. So while theta 2 plus theta 3 or theta 2, 3 is 59.49. So again, this is 90 minus 22.62. So 67.38. This is 90 degrees minus theta 2. So 53.13 degrees. So by sine law, delta BC1 as to sine 67.38 equals delta CD1 as to sine 53.13 degrees equals delta 1 as to sine 59.49 degrees. So therefore, delta BC1 is equal to 1.071425 delta 1. Delta CD1 is 0.928568 delta 1. So moment due to side sway of 1 is negative 6. EI is treated 1, then times delta 1 over length 6 square. This is 180. This 180 here is constant, arbitrary constant. You can make it 100 if you want. You can make it 200, and you can make it 300 or any value. So I select 180 because it is not so high, not so low also. So that moment AB due to side sway is negative 30 kilonewton meter. Moment BC due to side sways 1 is negative 6 times 1 times negative 1.071425 delta 1 over 5 square. This is negative because the rotation of chord BC is counterclockwise. So remember, this is the final position of C. So this is chord BC. From original BC to final position, it's counterclockwise. That's why it's treated negative over length square, which is 5 square. So 3, 4, the length of BC is 5. So times the same constant, 180, so 46.286 kilonewton meter. So finally, moment CD. So CD1 due to side sway is negative 6 times 1 times 0.928568 delta 1 over length 7.8 square. Square root of 7.2 square plus b square is 7.8. So times constant 180, so negative 16.49483 kilonewton meter. It is positive. This one is treated positive because the rotation of this chord is clockwise from original to its final position. Then we have moment DE, which is treated 0 in this case, this one. Then we have to set up moment distribution due to delta 4 at D. So this time AB is 0, the moment due to side sway of AB 0, so this is treated vertically upward. So imagine that this is held against side sway and only BC and DE, CD will have side sway in terms of delta 4. So this is delta 4 and this is parallel to CD, parallel, then CD, that's why that's delta 4. From the end of this line, we draw vertical line, so it's going down, and from C going down also to form this triangle here, so that this is the side C4F is the side sway displacement of BC, and the side C4F is the side sway displacement of CD. So enlarging it, so remember that the line through this vertex perpendicular to delta 4 or CC4, and the angle between that vertical line and this line here, since this line is perpendicular to CD, so that would be theta 3, and the line between the vertical and this side here, which is delta BC 4, is theta 2. So that's theta 2, that's theta 3. Therefore, this is 90 minus theta 2, 53.13 degrees. This angle is 59.49 and this angle is 67.90 minus 22.62, so 67.38 degrees. And this is 59.49 degrees. So by sine law, that's delta BC4, this is delta CD4. So by sine law, delta BC4 as to sine of 67.38 degrees equals delta CD4 as to sine 53.13 degrees equals delta 4 as to sine 59.49 degrees. So delta BC4 in terms of delta 4 is 1.071425 delta 4, and delta BCD4 is 0.928568 delta 4. So moment due to side sway of AB would be 0. AB due to side sway is 0 because this is held against side sway. Moment BC, the rotation is counterclockwise, and we have negative 6 times 1 delta BC4, which is in terms of delta 4 is 1.071425 delta 4. It is counterclockwise, so it is treated negative. So it is like this one. So it's negative 46.286 using the same formula. So negative 46.286. So it's negative this time because the rotation of BC is counterclockwise. Moment CD4 due to side sway. So the rotation is clockwise rather for BC. For CD4, it's counterclockwise. So this is the final position. So this is the displacement. So that's why it's counterclockwise. For CD, delta CD4. So it's negative. So negative 6 EI is 1 times delta CD4, which is negative. So that becomes positive. And it is the same as this. So it is positive 16.483. CD4 is 16.483 kilonewton meter. Just like this. So moment DE due to side sway would be negative 30 because the rotation of this cord is clockwise. So negative 30 kilonewton meter. So I hope that you understood the moment due to side sway for BC. It's negative because the rotation of the cord is clockwise. So negative 6 EI times positive 1.071425 delta 4. So it's like this. It's positive here over 5 squared. So that's why it's negative. And the values are the same. So that's it for this part. Let's proceed to the second part for computing the establishing equations and computing the values of R1 and R2. So these are multiplied by R1. This is the moment due to second phase. By the way, the moment due to first phase will all be zeros because the load 60 kilonewton, the only load of this frame, is acting at a joint. So for AB, there is no fixed moments. For BC, no fixed moments. Or CD, no fixed moments. DE, no fixed moments. So that's why moment due to the loads in the first phase would all be zeros. Moment due to side sway in the second phase would be these values, and moment due to delta 4 side sway would be this. So this will be in terms of R2. Then we need equations of statics to set up equations involving R1 and R2. So uh, we now distribute the moments due to sidesway delta 1 and compute the final moments at the joints. So remember, for this fixed end zero distribution factor, this one, negative 1 over 6 divided by, this is 1 over 5, the stiffness. So 1 over 6 divided by, negative 1 over 6 divided by 1 over 6 plus 1 over 5, negative 5 over 11. So this is negative 6 over 11. While this one is 1 over 7.8, this is 1 over 5. So that's why the stiffness is 1 over 5, negative 1 over 5 divided by 1 over 5 over 1 over 7.8. So in fraction, it is negative 39 over 64. Therefore, this one is negative 25 over 64. For this case, negative 1 over 7.8 divided by 1 over 7.8 over 1 over 6. So that's negative 10 over 23. So therefore, this one is negative 13 over 23. So we now apply the side sway moments. Remember, this is negative 30, negative 30. BC is positive 46.286, 46.286. CD is negative 16.483, negative 16.483, and this DE here is 0, 0, side sway moment. So we begin with this zeros, so 0, because the distribution factor is 0. So let's move to this joint B. So quantity 46.286 minus 30 times negative 6 over 11, negative 5 over 11 for this member, for this side. So negative 7.403 lakh. Then same quantity 46.286 minus 30.0 times negative 6 over 11 is negative 8.883 lakh. Then we proceed to this joint, quantity 46.286 minus 16.483 times negative 39 over 64 is negative 18.161 lakh. Then same quantity times negative 25 over 64 is negative 11.642 lakh. Negative 16.483 times negative 10 over 23 is 7.167 lakh. Then negative 16.483 times negative 13 over 23 is 9.316 lakh. Then carry over, since this is the distributed moment is 0, half of 0 is 0. Then half of negative 7.403 is negative 3.702. 0 here. Half of negative 18.161, half of negative 8.883. Half of 7.167, half of negative 11.642. Then half of 0 is 0 here, half of 9.316, 4.658. So let's proceed to this joint. Negative 9.08 times negative 6 over 11, 4.953 lakh. Negative 9.08 times negative 5 over 11, 4.127 lakh. Quantity negative 4.442 plus 3.584 times negative 39 over 64 is 0.523 lakh. Then same quantity times negative 25 over 64 is 0.335 lakh. Negative 5.81 times negative 10 over 23, 2.531 lakh. Negative 5.81 times negative 13 over 23, 3.290 lakh. Then carry over, half of 0, 0. Half of 4.127, 2.064. Half of 0.523, half of 0.4953. Half of 2.531, half of 0.335. Then half of 0, 0 here, half of 3.290, 1.645. 0.262 times negative 6 over 11, negative 0.143 lakh. 0.262 times negative 5 over 11, negative 0.119 lakh. quantity 2.746 plus 1.266 times negative 30 over 64, negative 2.28 lakh. Same quantity times negative 25 over 64, negative 1.462 lakh. 0.168 times negative 10 over 23, negative 0.073 lakh. Say 0.168 times negative 13 over 23, negative 0.095 lakh. Carry over, so 0 here, half of negative 0.119, negative 0.06, half of negative 2.28, negative 1.14, half of negative 0.140, negative 0.072, half of negative 0.073, half of negative 1.462, negative 0.731, 0 here, then half of negative 0.095, negative 0.048. Negative 1.14 times negative 6 over 11, 0.622 lakh. Negative 1.14 times negative 5 over 11, 0.518 lakh. Quantity negative 0.072 minus 0.036 times negative 39 over 64, 0.066 lakh. Same quantity times negative 25 over 64, 0.042 lakh. Then negative 0.731 times negative 10 over 23, 0.318 lakh. Negative 0.731 times negative 13 over 23, 0.413 lakh. Then carry over, so 0 here, half of 0.518, half of 0.066, 0.033, half of 0.622, 0.311, half of 0.318, 0.159, half of 0.042, 0.021. Then 0 here, half of 0.413, 0.206. 0.033 times negative 6 over 11, negative 0.018 lakh. 0.033 times negative 5 over 11, negative 0.015 lakh. Quantity 0.311 plus 0.159 times negative 39 over 64, negative 0.286 lakh. Same quantity times negative 25 over 64, negative 0.184 lakh. 0.021 times negative 10 over 23, negative 0.009 lakh. 0.021 times negative 13 over 23, negative 0.012 lakh. Carry over, so 0 here, half of negative 0.015, half of negative 0.286, negative 0.143, half of negative 0.018, half of negative 0.009, half of 0.184, then 0, half of negative 0.012. Negative 0.140 times negative 6 over 11, 0.078, so let's lock it finally. Negative 0.140 times negative 5 over 11, 0.065 lakh finally. And quantity negative 0.009 minus 0.004 times negative 39 over 64, so 0.008 lakh finally. Same quantity times negative 25 over 64, 0.005 lakh finally. Negative 0.092 times negative 10 over 23, 0.04 lakh finally. Negative 0.092 times negative 13 over 23 lakh finally. Half of 0.065, 0.032 lakh finally. Half of 0.052 here, 0.026 lakh finally. So adding the moments in this joint, we have negative 31.415 kilonewton meter. Adding the moments in this joint BA, negative 32.827. So here, positive 32.827. Adding the moments here, 24.42. Adding the moments here, negative 24.42. Adding the moments here, moment DC, negative 12.964. So adding these moments, it should be positive 12.964. Then adding the moments in this joint ED, 6.481. So that's it for this slide. So let's now have the distribution of the side swing moments due to delta 4. So remember for AD, this is 0, so we'll just put none at all. Then here, it's negative 46.286. Then here, for 16.483, positive 16.483. Then here, negative 30, negative 30. So distributed moment here, 0, 0. So this is also 0. So beginning with this joint, negative 46.286 times negative 6 over 11, 25.247 lakh. Negative 46.8 times negative 5 over 11, 21.039 lakh. Quantity negative 46.286 plus 16.483 times negative 39 over 64, 18.161 lakh. Same quantity times negative 25 over 64, 11.642 lakh. 16.483 times negative 10 over 23, 5.877 lakh. 16.483 times negative 13 over 23, negative positive 7.640 lakh. Then carry over half of 0 here, 0. Half of 21.039 is 10.52. Half of 18.161, half of 25.247. Half of 5.877, half of 11.642. Then 0 here, half of 7.64, 3.82. 9.080 times negative 6 over 11 lakh, negative 4.953 lakh. 9.080 times negative 5 over 11, negative 4.127 lakh. Quantity 12.624 plus 2.928 times negative 39 over 64, negative 9.477 lakh. Same quantity times negative 25 over 64, negative 6.075 lakh. 5.821 times negative 10 over 23, negative 2.531 lakh. 5.821 times negative 13 over 23, negative 3.290 lakh. Then half, carry over half, so 0 here, half of negative 4.127, negative 2.064, half of negative 9.477 here, half of negative 4.953 here, half of negative 2.531 here, half of negative 6.075 here, and 0, then half of negative 3.29 here. Negative 4.738 times negative 6 over 11, 2.584 lakh. Negative 4.738 times negative 5 over 11, 2.154 lakh. Quantity negative 2.476 minus 1.266 times negative 39 over 64, 2.280 lakh. Same quantity times negative 25 over 64, 1.462 lakh. Negative 3.038 times negative 10 over 23, 1.321 lakh. Negative 3.038 times negative 13 over 23, 1.717 lakh. Carry over, so 0 here, half of 2.154, 1.077, half of 2.28, 1.14, half of 2.584, 1.292, half of 1.321 here, half of 1.462 here, 0, half of 1.717. Then 1.14 times negative 6 over 11, negative 0.622 lakh. 1.14 times negative 5 over 11, negative 0.518 lakh. Quantity 1.292 plus 0.660 times negative 39 over 64, negative 1.190 lakh. Same quantity times negative 25 over 64, negative 0.762 lakh. 0.731 times negative 10 over 23, negative 0.318 lakh. 0.731 times negative 13 over 23, negative 0.413 lakh. Then carry over 0 here, half of negative 0.518, half of negative 1.19, half of negative 0.622, half of negative 0.318, half of negative 0.762. So 0 here, half of negative 0.413. Negative 0.595 times negative 6 over 11, 0.325 lakh. negative 0.595 times negative 5 over 11, 0.270 lakh. Negative 0.311 times negative 39 over 64, 0.286 lakh. Sorry, negative 0.311, then negative 0.159 close times negative 39 over 64, 0.286 lakh. Same quantity times negative 25 over 64, 0.184 lakh. Negative 0.381 times negative 10 over 23, 0.166 lakh. Negative 0.381 times negative 13 over 23, 0.215 lakh. Carry over 0 here, half of 0.27, half of 0.286, half of 0.325, half of 0.166, half of 0.184, then 0 here, half of 0.215 here. 0.143 times negative 6 over 11, negative 0.078 lakh. 0.143 times negative 5 over 11, negative 0.065 lakh. Quantity 0.162 plus 0.083 times negative 39 over 64, negative 0.149 lakh. Same quantity times negative 25 over 64, negative 0.096 lakh. 0.092 times negative 10 over 23, negative 0.04 lakh. 0.092 times negative 13 over 23, negative 0.052 lakh. Then carry over 0 here, half of negative 0.065, half of negative 0.149, half of negative 0.078, half of negative 0.04, half of negative 0.096, 0 here, half of negative 0.052. So negative 0.074 times negative 6 over 11, 0.04 final lakh. Negative 0.074 times negative 5 over 11, 0.034 final lakh. Quantity negative 0.039, then negative 0.02 close times negative 39 over 64, 0.036 final lakh. Same quantity times negative 25 over 64, 0.023 final lakh. Negative 0.048 times negative 10 over 23, 0.021 final lakh. Negative 0.048 times negative 13 over 23, 0.027 final lakh. Then half of 0.034 final lakh. Half of 0.027 final lakh. So adding the moments here, we have 9.394. Adding the moments here, we have 18.787 in this. Adding these moments, negative 18.787. These moments, negative 25.087. Adding these moments here, 25.087. These moments here, 24.156. Adding the moments here, negative 24.156. Adding these moments here, negative 27.077. Therefore, moment AB is moment due to R1 there due to sidesway delta 1, which is in terms of R1, and these moments here which are expressed in terms of R2. So moment AB is negative 31.415 R1, then plus 9.394 R2. Moment BA is equal to negative 32.827 R1 plus 18.787 R2. Moment BC is equal to positive 32.827 R1 minus 18.787 R2. Moment CB is equal to 24.420 R1 minus 25.087 R2. So moment CD is negative 24.420 R1 plus 25.087 R2. Moment DC is equal to negative 12.964 R1 plus 24.156 R2. Moment DE is 12.964 R1 minus 24.156 R2. Then finally, moment ED is equal to 6.481 R1 minus 27.077 R2. Then we set up equations by statics. First, considering the entire system, summation forces horizontal equals 0. So these are denoted NA shear at A and moment AB which is treated clockwise. Same is true at D, shear at E, normal at E, then moment ED which is treated clockwise. So summation forces X equals 0, horizontal equals 0, VA plus V sub E plus 60 equals 0. So that's the equation. Therefore, since V sub E, if we consider AB as a free body, there is MBA here. So summation moment at B, V sub A times 6 equals moment AB plus moment BA. Therefore, V sub A is 1/6 of quantity moment AB plus moment BA plus 1/6 of quantity moment ED plus moment DE equals negative 60. Multiply everything by negative 60, negative 6 rather, then substitute the value of moment AB, moment BA, moment ED, and moment DE into this equation to set up the first equation. So we recall that the moments AB in terms of R1 and R2 in the preceding slides are these values. Then the equation we left from the preceding slide is we have moment AB plus moment BA plus moment ED plus moment DE equals 6 times negative 60, so negative 360. So this is moment DE, which is this, equals negative 360. So combining like terms and simplifying, we have negative 44.797 R1, negative 23.052 R2 equals negative 360. So setting up the first equation, 44.791 R1 plus 23.052 R2 equals 360. Call this equation A. Then for the second equation, we cut this B here. Let's consider BCD. So we have shear at E and shear at B. Let's find O. So remember, these are the distances. So let's call that YZ. Then the reactions at B, we have shear at B, moment BC, normal at B, then here shear at E, moment at ED, which is assumed clockwise also, then NE. So before we sum up moments about O, let's compute Y and Z by similar triangles. So this is 6 meters. So Y as to 3 equals Z as to 5 equals 7.2 as to 4. Y as to 3, this is 3, equals Z as to 5, because this is 5 meters, equals 7.2 meters as to 4 horizontal. So Y is 5.4 meters and Z is 9 meters. So this distance 5 plus 9 is 14 meters. This distance is 6 plus 3, 9 plus Y 5.4, so 14.4 meters. Summation V sub B times 14 plus summation moment O equals 0, V sub B times 14, counterclockwise positive, plus V sub E times 14.4 equals moment AB plus moment ED. Since if we draw the free body diagram of BC, so we have here moment CB, then V sub B times 5 equals moment BC plus moment CB. Therefore, shear at B is 1/5 of moment BC plus moment CB. While V sub E times, if we separate the free body diagram of DE, there is moment DE here. So V sub E times 6 equals moment ED plus moment DE. So therefore, shear at D is 1/6 of moment ED plus moment DE. So this is 1/5 of moment BC plus moment CB, while times 14, while this is 1/6 of quantity moment ED plus moment DE times 14.4 equals MBC plus MED. Since 14 over 5 is 2.8, 2.8 MBC minus MBC, so we have 1.8 MBC plus 2.8 MCB. Then 14.4 over 6 is 2.4. 2.4 MED minus MED is 1.4 MED plus 2.4 MDE equals 0. Substitute the value of MBC, MCB, and MED and MDE from these equations here. 1.8 of quantity 32.827 R1 minus 18.787 R2 plus 2.8 of quantity MCB, so 24.420 R1 minus 25.087 R2 plus 1.4 of MED, 1.4 of 6.481 R1 minus 27.077 R2, then plus 2.4 of MDE, 2.4 of quantity 12.964 R1 minus 24.156 R2 equals 0. Combining like terms, then simplifying, 167.652 R1 minus 199.942 R2 equals 0. Equation B, solving equations A and B simultaneously, then we get R1 equals 5.61393. R2 is 4.70730. So from here, we can now solve MAB. MAB is negative 31.415 of 5.61393 plus 9.394 of 4.7073. MAB is equal to negative 132.141 kilonewton meter. Then MBA, negative 32.827 of 5.61393 plus 18.787 of 4.7073. So MBA is equal to negative 95.852 kilonewton meter. MBC therefore is positive 95.852 kilonewton meter. MCB is 24.420 of 5.61393 minus 25.087 of 4.7073. MCB is 19.000 kilonewton meter. So that means MCD is negative 19.000 kilonewton meter. MDC is negative 12.964 of 5.61393 plus 24.156 of 4.7073. MDC is 40.931 kilonewton meter. So that means MDE is negative 40.931 kilonewton meter. Finally, MED is 6.481 of 5.61393 minus 27.077 times 4.7073. MED is equal to negative 91.076 kilonewton meter. So that's it for this problem.